Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Here we are required to evaluate the orthographic projections of a line which happens to be perpendicular to HP and parallel to the vertical plane. Now the line CD, it is 50 millimeter long and it is perpendicular to the horizontal plane and it is parallel to the vertical plane. So we are required to draw the front view, top view and the left hand side view projections of this particular line CD, and we are also required to locate the traces of the line CD, that is horizontal trace and the vertical trace. Now let us first of all evaluate the spatial 3D coordinate location of this line CD with respect to horizontal plane, vertical plane and the profile plane. So here we have got the horizontal plane, vertical plane, and the intersection of the horizontal plane and the vertical plane will be providing us with the XY reference line. Now we know that since this line CD, it is perpendicular to the horizontal plane and it is parallel to the vertical plane. So this line's projection in the front view will be providing us with the true length projections of the line, while the projections of this line with respect to horizontal plane, that is the top view projections, will be the point view projections, because this line, it happens to be perpendicular to the horizontal plane. So first of all, let us evaluate the spatial coordinate location of this line with respect to the three reference planes over here. Now here we can see this is the line CD. This line CD, it happens to be perpendicular to the horizontal plane and it is parallel to the vertical plane. And another information we have been provided with, that is the end C of the line, it happens to lie 15 millimeter above the horizontal plane. So we can see that this line CD, which measures 50 millimeter, it is located in the space in such a way that one end C, it is located at a height of 15 millimeter above the horizontal plane, and this end C happens to lie 25 millimeter in front of the vertical plane. So this way we have been able to locate the spatial arrangement of this line CD with respect to the reference planes horizontal plane and the vertical plane. And now since this line CD, it happens to be parallel to the vertical plane, so the first projections we are going to obtain of this line CD will be on the vertical plane. And we know the basic fundamental of the projections of the line, that is whenever a line happens to be parallel to a given reference plane, its projection onto that particular reference plane will be revealing the true length projections of this particular line. So since this line CD, it happens to be parallel to the vertical plane, so the projections of this line on the vertical plane, that is the front view projections, they are going to provide us with the true length projections of this line. So the front view of this line will be represented as C dash D dash. So C dash D dash, it is the front view projection which is obtained on the vertical plane. And because this line CD happens to be parallel to the vertical plane, so these front view projections, they are going to present with the true length projections of this line, and it will measure 50 millimeter. And once we look at this particular line from the top, so since this line CD happens to be perpendicular to the horizontal reference plane, therefore the top view projections of this line will be converted as a point view projection, wherein points D and C, they are going to converge or they are going to coincide with each other, and we are going to get the point view projections of this particular line CD onto the horizontal plane, that is in the top view projection. So once we have obtained the true length projections of this line in the front view and the top view projections of this line in the top view projections over here. Now we are going to establish the relationship between the front view and the top view projections, and this relationship will be established by drawing these two projection lines over here. So once we draw these two projection lines, so we will be able to establish the relationship between the true length front view projections which have been obtained on the vertical plane and the point view top view projections which have been obtained on the horizontal plane. So since this line happens to be perpendicular to the horizontal plane and parallel to the vertical plane, so this line will have only the horizontal trace and this line will not be having any vertical trace. Why? Because this line happens to be parallel to the vertical plane, so therefore it is not going to intersect with the vertical plane at any given point of time. So here we have to extend this line CD in order to obtain the horizontal trace of this particular line. So this is the line CD. So once we extend this particular line, then whatever will be the intersection of this line with the horizontal plane, this will be giving us the horizontal trace of the line. So this point will be represented as H, and now the horizontal trace will be the perpendicular distance of this point of intersection from the XY reference line. So from this point H, we are going to draw a perpendicular onto the XY reference line over here, and this distance will be giving us the horizontal trace of a line. So this H distance will provide us with the horizontal trace of the line. So this way we have been able to evaluate front view projections, top view projections, and the horizontal trace of the line. Now let us proceed with the evaluation of the left hand side view projections of this particular line. So when the observer is going to look at this line from the left hand side, so we see that the projections of this line, they will be obtained on the profile plane which is located on the right hand side. So the points C and D, so they will be projected in the left hand side view onto the profile plane in such a way that we are going to obtain the true length projections of this line onto the profile plane. Why? Because this line CD, it is also parallel to the profile plane which is shown over here. So since this line CD happens to be parallel to the profile plane, so C double dash D double dash projections which have been obtained onto the profile plane which is located on the right hand side, they will reveal the true length projections of this line in the left hand side view. Now we have to establish the relationship between the left hand side view and the front view. We have to draw these two projection lines over here. So once we draw these two projection lines corresponding to the point D dash, similarly we have to draw these two projection lines corresponding to the point C over here. So corresponding to the point C or C dash, once we draw these two projection lines, so we have been able to develop the relationship between the left hand side view and the front view. Similarly, we are also required to establish the relationship between the left hand side view and the top view. So this projection line and this projection line. So this projection line, this will be parallel to the XY reference line, and this projection line, it will be perpendicular to the horizontal plane. So once we draw these two projection lines, so we will be able to establish the relationship between the left hand side view and the top view projections in these 3D spatial representation over here. Now let us proceed with the construction of 2D orthographic projections of this particular line. So here we will be drawing the front view projections, the top view projections, and the left hand side view projections of this line into the vertical plane, horizontal plane, and the profile plane. So here we have got the XY reference line, the X1, Y1 reference line with respect to the profile plane over here, and the HP and VP. Now we know that the front view of this line, it is going to represent the true length of this line, and the end C of the line, it is located 15 millimeter above the horizontal plane over here, or the XY reference line over here. So we can draw, first of all, a locus line over here, one projection line we can draw corresponding to the locus line corresponding to this particular projection C dash D dash over here. Now this C dash D dash projection, it is located 15 millimeter above the XY reference line or above the horizontal plane. So we have measured the distance of the point C dash from the XY reference line as 15 millimeter. The moment we mark this point 15 millimeter, so we know that the true length of this particular line, it is projected in the front view projections. So this front view projection of this line will be represented by C dash D dash, and it measures 50 millimeter. So this distance between C dash and D dash, so this length of the line, this measures 50 millimeter, and the C dash D dash representation of this particular projection in the front view, it represents the true length projection of this particular line. So having obtained the front view projections, now we need to obtain the top view projection. So we know that in the top view, that is onto the horizontal plane, so there is point view projection representation of this particular line onto the horizontal plane, and this point D and C, it will be located at a distance of 25 millimeter in front of the vertical plane, that is below the XY reference line. Why below the XY reference line? Because the horizontal plane is to be rotated in the clockwise direction over here. So the moment we rotate this horizontal plane in the clockwise direction, so we will be obtaining this point D and C 25 millimeter below the XY reference line in the first quadrant. So we mark this distance 25 millimeter, and over here the point view top view projection of this particular line DC will be obtained onto the horizontal plane. Now we have obtained the front view projections. We have also obtained the top view projections of this line. Now we will be proceeding with the construction of the left hand side view projections of this particular line CD. So we know that in the first quadrant, the left hand side view projections, they will be drawn on the right hand side of the front view. So this is the front view projection. So on the right hand side of this particular front view, we are going to get the construction of the left hand side view projections of this particular line. But before that, we have to draw the horizontal trace. So in order to draw the horizontal trace, so these are the front view projections. So in order to develop the horizontal trace of this particular line, so we need to extend the front view projection C dash D dash. So please check, we have to extend this projection of the front view C dash D dash till it meets the XY reference line. So in the 3D projections, we are extending the line and we get this as the horizontal trace, and from here we draw the perpendicular projection line onto the XY reference line. Whereas here in the orthographic projections, we do not have the 3D coordinates of this particular line available with us. So what we do, whatever front view projections are available C dash D dash, we will be extending these projections C dash D dash such that this front view elevation projection, it should itself intersect with the XY reference line, or its extension should intersect with the XY reference line. So here, once you extend C dash D dash, it will meet the XY reference line at the point H dash. So once I extend this front view projection line, that is D dash C dash, so that it meets the XY reference line. So this point of intersection of the extension of this front view elevation projection C dash D dash, this will be called point H dash. And from point H dash, I need to draw a perpendicular onto the extension of or the projection of the top view projections over here which are appearing onto the horizontal plane. So from H dash, I will be dropping a perpendicular onto the top view projection point view over here. So from H dash, once I drop a perpendicular up to the top view projection, that is DC, so this point which I am going to obtain will be labeled as point H. So once I obtain this point H, now the distance between H dash and H, it will provide us with the horizontal trace location of this particular line CD over here. Now having obtained the horizontal trace and front view and top view projections, now we will proceed with the construction of the left hand side view projections corresponding to this particular line CD. So from the points D and C, once again as usual, this distance from the vertical plane, so this is equal to 25 millimeter. So this distance has to be transferred in the profile plane from this x1 y1 reference line. So for that, we are going to draw a horizontal locus line passing through the points of the plan in the top view, that is points D and C over here. So once we extend a horizontal locus line onto the x1 y1 profile plane, so this point has been obtained, which is at a distance of 25 millimeter from the vertical plane. So this needs to be transferred into the profile plane. So here we are going to keep a needle point as the intersection of the reference lines xy and x1 y1. Open compass is equal to this radius and rotate this particular distance of 25 millimeter onto the profile plane. So once I rotate this distance corresponding to the distance of this point from the xy reference line, that is from the vertical plane, so I will be able to obtain this point over here. So from this point, so this line or the arc is called transfer arc over here. So this is called transfer arc. So this way we are able to transfer the distance from the vertical plane from the top view into the left hand side view projections which we are required to obtain. Now having obtained this point, now from this point we are going to draw a vertical projector line in the upward direction. Now in order to locate the projections of this line in the left hand side view, we need to draw two horizontal locus lines, one from the point C dash and another one from the point D dash over here. So the point of intersection of the horizontal locus line which is emerging from the point C dash, this will provide us with the location of the point C double dash in the left hand side view. Similarly, the intersection of the horizontal locus line emerging from the point D dash of the elevation with the vertical projector line which is emerging from this point, so this will be providing us with the location of side view projection corresponding to the point D of the line. So having being able to obtain point C double dash and D double dash, we are going to join C double dash projection with D double dash projection. So this way we know that because this line happens to be parallel to the profile plane as well, because it is perpendicular to the horizontal plane, so it is parallel to the profile plane. So since this line happens to be parallel to profile plane, so we have been able to obtain the true length projections of this line in the left hand side view projections over here. So we have evaluated the front view projections, the top view projections and the left hand side view projections of this line into the 2D orthographic projections. And besides this, we have also discussed about the spatial orientation or location of this line with respect to horizontal plane, vertical plane and the profile plane. And we have also evaluated the horizontal trace of this particular line over here. So since this line, it is parallel to the vertical plane, so it's not going to intersect with the vertical plane, so it won't be having any vertical trace. And since this line, it is perpendicular to the horizontal plane, so it will be intersecting with the horizontal plane, and this point of intersection of this line with the horizontal plane has provided us with the location of horizontal trace of this particular line. So this is all for today. So I hope that through this discussion you would have understood about how do we obtain the spatial or 3D orientation of a line with respect to the three reference planes, that is HP, VP and the profile plane. And we have also discussed about the procedure to obtain the 2D orthographic projections of this line, that is front view, top view and the left hand side view projections of the line, along with the location of the traces of this line. So we will be continuing with further discussion on few more cases of orthographic projections of the line in the coming lectures. So thank you very much. Thanks a lot.